So we're trying to solve this equation here within 0 to 360. I noticed that both of these terms have a sign in common, so let's take out a sign to the front. This should be good because if I distribute sine times 1 is sine times that is that. So I know this is legit. So this times this equals 0, so you set this equal to 0 and you set this equal to 0. Here, let's subtract the 1 and then divide by -2. Remember, the best way of doing these equations is to think of the unit circle. Remember that on the unit circle, sine is a y coordinate on the unit circle. X is an angle. So can you tell me an angle where the y coordinate is 0? On the unit circle, where do you go so that the y coordinate is 0? That occurs here and that occurs there, yeah? Because right here, the y coordinate, 0. Here, the y coordinate, 0. What's that angle? 0. What's that angle? 180. And that's what this angle called x has to be. So from this equation, you discover that x has to be 0, x has to be 180. Technically, you can call it 0 or you can call it 360 because it's pretty much the same thing. They're coterminal. What about here? Cosine, remember on the unit circle, cosine is the x coordinate. It doesn't help that x is actually the variable itself. I really wish they'd choose a variable other than x, but whatever. Remember, cosine is the x coordinate. I want the x coordinate to be -1/2. Look at your unit circle. Where do you have x coordinates of -1/2? That'll happen here, that'll happen there. And if you look at your unit circle, that's 120, that's 240. So this tells us that this equation, that variable x, 120 or also 240. So collectively all together, our answers would be all of these here. Because the answer had to be between 0 and 360, and all of these numbers are between 0 and 360. This one's a little more interesting. So I have a fraction plus a fraction. I want to add the two fractions into one. We need a common denominator. So let's multiply this by that denominator, and let's multiply this by this denominator. So I multiplied this top and bottom by that piece, and I multiplied this blue top and bottom by this denominator, and so on and so forth. And now let's write this down again nice and pretty. And maybe what we can do is up here, we can expand this. And here, that's just going to be cosine squared. And let's leave the bottoms the same. So when you expand that there, and if you expand it and combine like terms and simplify, you get right here. That's just cosine squared. The bottoms are the same. And because the bottoms are the same, we can combine two fractions into one. Now, looking at the numerators, if you notice these pieces here, if you look at your trig identities, how much is sine squared plus cosine squared? Sine squared plus cosine squared is just 1. So all of that is just 1. And then 1 plus the 1 gives us 2. So that 1 plus that 1 is 2. Now in the numerator, I can actually factor out 2 to the front as a common factor. So this 2 got pulled out to the front. I'm left with this inside. And this is so convenient because these actually knock out. So these are gone, and all that's left is 2 over cosine, like that. But then I got rid of that denominator by multiplying both sides by cosine because these eliminate, these reduce away. And so I have 4 cosine equals 2, 4 cosine equals 2. Divide by 4, and reduce. And we get, these are gone, we get cosine x equals 1/2. And now I propose that you look at this by interpretation. The unit circle is here. Cosine is an x coordinate. Where on this map is an x coordinate? 1/2? That'll happen here, that'll happen there. And this should be 60 degrees, and this should be 300 degrees. But in the directions, nope, they want radians, not degrees. So I believe that 60 degrees is the same as pi over 3, and this one should be 5 pi over 3. And so this angle called x, the value of it could be either pi over 3 or 5 pi over 3, both of which are safely within this interval. Final answer.